Hi, in this video I'm going to go over logistic regression assumptions. As we see here, we have the basic formula for the logit function, or the log function, p over 1 minus p. What we finally get as the output, the log odds of the intercept plus the coefficient of the first variable for the log odds. I'm going to first go over some of the assumptions that really don't need a test. I am going to then go into some that do need a test, and I will have a later video talking about how to test for those assumptions. If you find this video helpful, please like and subscribe. First is checking to see whether or not we have a binary or ordinal variable for our dependent variable. The binary, I think everyone understands, it's two variables. The ordinal is just a number of them. So an example of binary is fail, success. Another binary example is vaccinated, not vaccinated. Going into ordinal, you could have something like Republican, Democrat, Independent, or Labor Party, Progressive Party, and Conservative Party. So those are types of examples for binary and ordinal. The second assumption is a large sample size. Depending on your field, if you're in biology, political science, a social science in general, a more hard science, you're going to have to ask your experts. You're going to have to talk to your experts because they're going to know what generally you're going to have. If you're dealing with this as just a straight statistics course, probably about 500 observations would be good. Generally speaking, depending, again, this is also depending not only on the field and what you're studying, but on how many variables you have. I previously worked at a firm where I would look at literally millions of observations because we had hundreds of variables. And so it depends. You know, that was more of a business marketing type of situation, but look to the experts in your field. There's already going to be an established sample size or minimum, and it would be very rare for you to be in a situation where you don't have that type of expertise that you're going to be able to lean on. The third is independence. So observations are independent of each other. They're not repeated. They're not matched. You're looking strictly for someone giving their opinion once, seeing something happen once. You're not looking for time series. You're not looking for matched pairs. They have at max one input for that variable. They don't have several inputs for that variable. The next is linearity of independent variables and log odds. This is looking at the log odds of each independent variable and making sure they're linear to the dependent variable. I'll go over some ways to test for this. Last is that none or very little multicollinearity between independent variables. That is to say that you don't have two variables really correlated that much that are independent. So in America, we have, we have the Republican Party, and they're very pro-life or anti-abortion. So if you had both of the variables together, there would be this high correlation between the two that you probably want to remove one of them because one usually infers the other. At the end of the day, you want to stay away from redundant variables that encompass each other. I'm sure most of you have experience with multicollinearity with linear regression, and it works very similar to this. I'm also going to go over tests for how to deal with multicollinearity with your logistic regression. If you found this helpful, please like and subscribe. Thanks for watching, and stay nerdy, my friends.